Now we will talk about the application of the rank of the matrix. Okay, the application of the matrix ranking or rank. So we will make two examples for homogeneous equation and non-homogeneous equation. Let's see how we can use the rank to see the solution set of those equations. For square matrices, for square matrix, and let's assume the dimension will be n by n. So it's a square matrix. In order to solve AX equals to B, to get the solution set of X, we can use the inverse matrix as we talked before. X will be equals to A inverse B, right? Where this inverse matrix can solve differently. Can either use the Gauss-Jordan method, or you can use the method one for the lower dimension, that is the cofactor matrices divided by the determinant of A. Okay. So if my A is now singular, so the singular means now 0. That means the rank of A has to be equals to n. So the rank of A is equals to n. That means the determinant of A is now 0. So the A inverse matrix will be exist, right? So the A inverse, and that leads to A inverse, will exist. In that sense, you know A inverse, you know B, then you know the solution site. And there is one situation is for non-homogeneous equation. So non-homogeneous equation problem means that my B is now 0. And if A inverse will be exist, the determinant of A is now 0. So you can directly get your X will be A inverse B. And this solution set will be non-zero solution, or you can say non-trivial solution. Then the second situation is called homogeneous equation. Homogeneous equation means that my B will be equals to 0. That is the homogeneous equation. Well, how to get, so for homogeneous equations, how to get my solution set is non-trivial or non-zero. Okay, so in order to get the X is non-zero, okay, the X is non-zero, this B is 0, then you have to make the determinant of A is 0. So that leads to the determinant of A has to be equals to 0. That means this A is a singular matrix. Or you can also say the rank of A is smaller than n, so that the determinant of A will be equals to 0. Then the solution will be non-zero. The solution X will be non-zero. And since the rank of A is smaller than n, so that you will have infinite solution. So it's infinite solution. And this leads to our topic of eigenvalue and the eigenvector problem.